Hi, and welcome to the guided practice for lesson 14.1. This is all about rational and irrational numbers. So we'll get started here, and we're asked to write each fraction or mixed number as a decimal. Well, we can divide this. 2 divided by 5. If you put it in a calculator, you're going to get this. And just to show you real quick, let me pull this over to the side, and I could do this. 2/5 is equal to, I call it cowboys and horses. The 2 is the cowboy and it sleeps inside, and the 5 is the horse and it sleeps outside. And 5 does not go into 2. Add a decimal, 5 will go into 20 4 times, and there is your 0.4. And that's how you do any of these things. It's the top number divided by the bottom number. And let's go to number 2. 8 divided by 9. That ends up being a repeating decimal, 0.8 repeating. Because again, if you have 9 going into 8, doesn't go into 8. Whoops, I'm going to have to bring this down just a little bit. So it won't go into 8, but it will go into 80 8 times, which is 72, 8, 0, bring that down. It just keeps on going to 0.8888 and so on. The rest of these, well, 3 3/4, that's 3 point, and then let me show you. So it's 3.75. This 3 is that, and then the 3/4 is 0.75. 3/4, 75 cents. 7/10, when you divide that out, you get 0.7. And 2 3/8, that ends up being 2.375. And I encourage you to test this out in a calculator. 3 divided by 8, you should get 0.375. 5 divided by 6, that is 0.83, and only the 3 is repeating. So when you look at this in a calculator, it'll say 0.83333, and so on. Mixed number. So write each decimal as a fraction. Now, if I write, let's see, 0.675. This 5 is in the thousandths place, so it's 675 over 1,000. And then when you simplify that, that's where you get this decimal here, or that fraction here, 27 over 40. I think you can divide them both by, well, 25 probably. Yeah, divide them both by 25 and you get that. 5.6, well, the 5 ends up being, this is going to be a mixed number, and you get that because the 5 is here, and the 0.6 is 3/5, and you get that from 6.6. I'm looking at how I can erase this here. So if I have well, trying to engage my pencil, so 0.6 is 6 over 10, which equals 3/5. See, that's how you get the 3/5 right there. Next, number 9, 44. That's 44 hundredths, which simplifies to, oops, hold on. I gotta get, my goodness, I'm having a hard time right now. There, 11/25. And now this is where things get a little bit weird. And we're going to show how you go from 0.4 is equal to, how is 0.4 equal to 4/9? So 4/9 is going to show up right down there. And what they're doing is they're saying, well, if you multiply, if x, so they start with the idea that if x is equal to 0.4 repeating, then 10x would be 0.4, and that when you multiply this side by 10, it moves the decimal over. So 10x would be, oh, 10x would be 4.4 because it just moved the decimal over 1. Kind of a weird idea. And then if you subtract an x, then this ends up being 9x. And if you subtract an x here, which x is, in the original statement, x is equal to 0.4 repeating, then, subtract one of those. This is not my favorite way to do this. And then there you have 9x equals 4, divide both sides by 9, and you get this. I think really in practice, you don't have to know how to do all this. I think the important thing is to know that 0.4 repeating is equal to 4/9. And then they do this whole thing where if you have 100x, then you have to move the decimal 2 times, and you have 26.26, and the 26 is repeating like that. And if you subtract an x, then this is 99x, and x is supposed to be equal to one of those, and if you subtract that, you get 26. See, because all of these will just cancel each other out, and you end up with 26. And then 26 divided by 99, that is our fraction. See, so I think that the important thing, again, is really not that you can do all this, because frankly, it's a little bit over the top, but it does officially explain why 0.26 is equal to 26 over 99. Anyway, to continue. Now, this right here, we have x squared is 17, so x is equal to plus or minus the square root of 17. See, let me take a step back here. If a similar problem, if x squared is equal to, let's say, 16, then x is equal to 4, right? Because 4 times 4 is 16, and this squared means some number times itself. So x would have to be 4. But not only could x be 4, not only could x be positive 4, but x could also be negative 4, because negative 4 times negative 4 is positive 16 also. So that's where this comes from. It's called plus or minus. That means your answer could be positive, or it could also be negative. So let's go with the rest of this here. I'm going to erase this stuff here. And what we have is we have this. So x is going to be plus or minus the square root of 17, which is, and this means about, plus or minus, boy, it's a little bit over 4. It might be like 4.1 or 4.2. So 4.1. Okay. And just to tell you, how did I know it'd be 4.1? Well, let me show you something else. If I have something like the square root of 26, well, I don't know what that is, but I know what the square root of 25 is. The square root of 25 is 5, because 5 times 5 is 25. So 26, the square root of 26 must be a little bit more than 5. Maybe that's 5.1 or something like that. Or I can go with, how about the square root of 48? I don't know what that is, but I know what the square root of 49 is. That's 7, because 7 times 7 is 49. So that means the square root of 48 must be something like 6.8 or 6.9 or something like that. So that's how you approximate these things, and that's what I did with number 13. Now, number 14, let's see. What you can do with this is, if x squared, if some number squared is 25 over 289, then you can take the square root of each of them. You take the square root of the whole thing. So you take the square root of 25 over the square root of 289. And the square root of 25, well, that's pretty easy. That's 5. And the square root of 289, well, that's 17, because 17 times 17 is 289. And again, with any of these square roots, you have to recognize that this could be the positive or the negative. So 5 times 5 is 25, but negative 5 times negative 5 is also 25, and negative 17 times negative 17 is 289. So you need to take that into account. That's what that's for. Now, the other one here, this is called the cube root. This is called the cube root. So it's asking what times itself 3 times is 216. So I can make an easy one. So the cube root of something is equal to 8. So that something has to be 2, because the cube root of 8 is equal to 2. Because 2 times 2 times 2 is 8. Now, what times itself 3 times is 216? Well, that is, so the cube root of 216 is 6. 6 times 6 is 36, and 36 times 6 is 216. That's how that works. Okay, so we're going to approximate this. So square root of 5, let's see. Just under that is the square root of 4, which I know is 2. And then the other one is square root of 9, which is 3. And it looks like it's pretty close to 2, so I'm going to call this 2.1 or 2.2, something like that. And it's 2.2. Okay, the square root of 3. Square root of 3, well, I know the square root of 1 is 1, and the square root of 4 is 2, and it's closer to... So this is closer, so I'm going to call this like 2.5 or something like that, I'm guessing. Let's see. Oh, 2. I'm sorry, it can't be 2.5. That didn't make sense. 1.5, I should have said. Not enough. It's closer to 2 than it is to 1, so that's why it's 1.7. And square root of 10. Well, that is in between. Well, the square root of 9 is 3. The square root of 16 is 4, and it's closer to this. So I'm going to call this 3.2 maybe. Let's see. 3.2. Nailed it. Okay. And what is the difference between rational and irrational numbers? Well, this is the difference. Rational numbers can be written in the form of a over b, where a and b are integers and b is not equal to 0, and irrational numbers cannot be written in this form. So rational numbers are fractions of integers. That's what this is. So a rational number would be like 2/3 or 0.4, because that can be written as 4 over 10. And that's where that's the a over b. Written irrational numbers can be written as a over b, where they are integers. See, 2 is an integer, and so is 3. 4 is an integer, and so is 10. So that's what this is all about. Those have to be integers, but b cannot be 0. So the bottom number cannot be 0, because you can't divide by 0 anyway. And there you go. That's it. That's what you got to know for this rational and irrational numbers. Thanks for watching.